Also, yesterday we discussed about the standard form of the hyperbola and properties of hyperbola and various forms of the hyperbola. So today we will discuss some problems. So first of all, before that, so let us discuss the a small concept that is asymptotes. Asymptotes of the curve. So what is an asymptote? So let us discuss. So here, see what is the asymptote of a curve. So an asymptote is a tangent to the curve at infinity. So that means asymptote is a straight line so that touches the curve at infinity. So that is called the asymptote. So here observe the graph. So in this graph, the curve is y equal to 1 by x. And here observe the graph as the x values are increasing from 0 to infinity, the graph is the curve is coming closer and closer to the x-axis. So it may contact at infinity value. So therefore, here this line that is x-axis touches the curve at infinity. So therefore, here x-axis is an asymptote of the curve. So and also here the y-axis also is very near to the curve. So here y-axis also called the asymptote. In this x-axis is called the horizontal asymptote and y-axis is called vertical asymptote. So next here, so for the hyperbola, the asymptotes are given by, here the hyperbola equation is x square by a square minus y square by b square equal to 1. Then for this hyperbola, the asymptotes are given by x by a square minus y by b square equal to 0. So that is, if we simplify this, we will get y equal to plus or minus b by a x. So these are the asymptotes of the hyperbola. So next one. So let us solve some more problems. Here, the question is find the equations of the tangents to the hyperbola 3x square minus 4y square equals 12, which are parallel and perpendicular to the line y equal to x minus 7. So this is very important problem. So for 4 marks, so we already discussed a similar problem in the ellipse. So here also, let us discuss the question. So given hyperbola equation is 3x square minus 4y square equal to 12. So now transform the equation into the standard form. So that is 3x square by 12 minus 4y square by 12 equal to 1. So on simplify, we get x square by 4 plus y square x square by 4 minus y square by 3 equal to 1. So here a square is 4 and b square is 3. And it is given that the tangent is parallel to the equation y equal to x minus 7. So that is x minus y plus, sorry, x minus y minus 7 equals 0. So the equation of the tangent is parallel to this equation. So therefore, the equation of the tangent is given by x minus y plus k equal to 0. So this is the equation of tangent, which is parallel to the given line. So now writing the equation in the form of y equal to mx plus c, here we have y equal to x plus k. So in this, the slope of the tangent is 1 and the c value is k. So now the condition for a line to be a tangent to the hyperbola is c square equal to a square m square minus b square, where the values here c, that is k square, is equal to a square is 4 into m, that is 1 square minus b square is 3. So on simplifying, we get k square equal to 1, then k equal to plus or minus. So now substitute this value in the tangent equation. So therefore, the equation of the tangent is x minus y plus or minus 1 equal to 0. So in the second case, the tangent is perpendicular to the equation. So see here, the tangent is perpendicular perpendicular to y equal to x minus 7. So now writing the perpendicular equation, so that is equation of tangent minus x minus y plus k equal to 0. So now writing this equation in the form y equal to mx plus c, so we have y equal to minus x plus k. Here the slope is minus 1 and c is k. So now apply the condition that c square equal to a square m square minus b square. So we have k square equal to 4 into minus n square minus 3. So on simplifying, we get k square equal to 1. So that is k equal to plus or minus. So now write the value of k in the equation. So that is equation of tangent is minus x minus y plus or minus 1 equal to 0. So which can be written x plus y plus or minus 1 equal to 0. So this is the solution of the given equation. So next we will go to the next one.
అప్డేట్ చేయాలా అని అడుగుతుంది.
So let us discuss one more problem. The question is, prove that the point of intersection of two perpendicular tangents to the hyperbola x square by a square minus y square by b square equal to 1 lies on the circle x square plus y square equal to a square minus b square. So here in the question, it is given that the point of intersection of perpendicular tangents. So for tangents, we need a point. So let P x1, y1 be the point of intersection of perpendicular tangents to the hyperbola, that is x square by a square minus y square by b square minus 1 equal to 0. So we already know that the equation of the tangent having slope m is y equal to mx plus or minus under root of a square m square minus b square. And since P is the point of intersection of the tangents, therefore P lies on the line. So now substitute the point, we get y1 equal to mx1 plus or minus under root of a square m square minus b square. So take mx1 left side. So we have y1 minus mx1 equal to plus or minus under root of a square b square a square m square minus b square. So now squaring on both sides, that is y1 minus mx1 whole square equal to plus or minus under root of a square m square minus b square whole square. So on simplifying, we get, so left side, that is y1 square plus m square x1 square minus 2 m x1 y1. On the right side, square root gets cancelled. So a square m square minus b square. So now take all the terms to left side. Here y1 square plus m square x1 square minus 2m x1 y1 minus a square m square plus b square equal to 0. So now take x1 square m square as common. So we have x1 square minus a square into m square minus 2x1 y1 into m plus y1 square plus b square. Here, observe this is a quadratic equation in m. So let the roots of the equation as m1, m2. Now the product of the roots, that is, we have the formula that's constant by coefficient of m square here. The product of roots means that is m1 into m2 equal to y1 square. Constant term here, the constant is y1 square plus b square by the coefficient of m square, that is x1 square minus a square. So here what are m1, m2? M1, m2 are the slopes of the tangents. Here the tangents are perpendicular. The tangents are given as perpendicular. Therefore, the product of the slopes is -1. So therefore, -1 equal to y1 square plus b square by x1 square minus a square. So on cross multiply, we get -1 into x1 square minus a square equal to y1 square plus b square. So on simplifying, we get x1 square plus y1 square equal to a square a square minus b square. So therefore, the locus of the point P is given by x square plus y square equal to a square minus b square. So this is the equation of a circle. This equation represents a circle. That means the point P lies on the circle. So therefore, the point of intersection of perpendicular tangents lie on the circle x square plus y square equal to a square minus b square. So next, we will discuss one more problem. So this is the first problem in exercise 5A. So the question is, one focus of a hyperbola is located at the point 1 comma minus 3, and the corresponding directrix is the line y equal to 2. Find the equation of the hyperbola if its eccentricity is 3 by 2. Okay, in the question, so what is given here? One focus is given here, 1 comma minus 3, and the directrix equation also given, that is y equal to 2, and eccentricity e equal to 3 by 2. Then he is asking for the equation of the hyperbola. So now discuss. So let P x1 y1 be any point on the hyperbola. So by the definition of hyperbola, we have SP by PM equal to E. So that is SP equal to E into PM, squaring on both sides. We already solved this type of problems in previous chapters, ellipse and parabola. So similarly here also, squaring on both sides, here we get SP square equal to E square into PM square. SP, that is the distance between the focus and the point. Here the focus is 1 comma minus 3 and the point is P x1 y1. SP square, that is x1 minus 1 whole square plus y1 plus 3 whole square equal to the eccentricity, that is 3 by 2 whole square into PM. Here what is PM? PM is the perpendicular distance from the point to the directrix. We already know. So therefore the perpendicular distance is given by modulus of y1 minus 2 by under root of 1 square. So which is equals to y1 minus 2. So this is the PM. So now substitute the value of PM here, y1 minus 2 whole square. So on simplifying, x1 square plus 1 minus 2x1 plus y1 square plus 9 plus 6y1 equal to 9 by 4 into y1 square plus 4 minus 4y1. So now cross multiply 9 on both sides. Here we get 4 into x1 square plus y1 square minus 2x1 plus 6y1 plus 10, which is equals to 9 into y1 square plus 4 minus 4y1. So on multiplying 4 inside and 9, we take all the terms to left side. So by simplifying, we get the equation 4x1 square minus 5y1 square minus 8x1 plus 60y1 plus 4 equal to 0. So the locus of the P is given by 4x square minus 5y square minus 8x plus 60y plus 4 equal to 0. So this is the equation of the required hyperbola. So here in the Roman number one, all these questions are important for 2 marks question. So let us discuss the next one. So the problem is if the lines 3x minus 4y equal to 12 and 3x plus 4y equal to 12 meets on a hyperbola is equal to 0, then find the eccentricity of the hyperbola is equal to 0. Here, the given two lines meet on a hyperbola s equal to 0. So here, the equation of the hyperbola is given by the combined equation of the straight lines. Since these two straight lines are meeting on the hyperbola, we can write the equation of hyperbola as the combined equation of the given straight lines. So that is 3x plus 4y into 3x minus 4y equal to 12 into 12. So on multiplying a plus b into a minus b, we have 9x square minus 16y square equal to 144. Transform the equation to the standard form. So we get x square by 16 minus y square by 9 equal to 1. So in this equation, we have a square equal to 16 and b square equal to 9. So here we have to find the eccentricity. So the formula for eccentricity is E equal to under root of a square plus b square by a square. So that is under root of 16 plus 9 by 16. That is square root of 25 by 16. So therefore the eccentricity is 5 by 4. So next one. So the question is find the equations of the hyperbola whose foci are plus or minus 5 comma 0. The transverse axis is of length 8. So here given so what is given here? Foci plus or minus 5 comma 0. So we already know the coordinates of foci, that is plus or minus ae comma 0. So here ae value is 5. And also given that the distance between foci is 8. So we already know that the distance between foci SS dash is So here the distance between foci is not given. Here the given it is as the transverse axis, length of the transverse axis. So here this is the length of the transverse axis. The length of the transverse axis is 8. So that is 2a. 2a equal to 8. A equal to 4. So and also we have a equal to 5. That is substitute a value 4. 4 into e equal to 4 equal to 5 by 4. And also we have b square equal to a square into e square minus 1. So now apply the value a, that is 4 square into e 5 by 4 whole square minus 1. I'm simplifying. So we get 25 by 16 minus 1. So that is 25 minus 16 by 16. So 16 will get cancelled here. The b square value is 9. And also here a value is 4. Therefore a square is 16. Therefore the equation of the ellipse, equation of the hyperbola is given x square by a square, that is 16, minus y square by b square, that is 9, equal to 1. So this is the equation of the hyperbola. So next, let us discuss one more problem. So the question is here, find the equation of the hyperbola whose asymptotes are the straight lines x plus 2y plus 3 equal to 0, comma 3x plus 4y plus 5 equal to 0, and which passes through point 1 comma minus 1. Here the asymptotes are given. Asymptotes of the hyperbola are given. So if you have the asymptote equation, we can write the equation of the hyperbola. So that is the combined equation, that is x plus 2y plus 3 into x plus 2y plus 3 into 3x plus 4y plus 5 plus k equal to 0. So this is the equation of the hyperbola. So now this hyperbola passes through the point 1 comma minus 1. So substituting the value here, we have 1 plus 2 into minus 1 plus 3 into 3 into 1 plus 4 into minus 1 plus 5 plus k equal to 0. So on simplification, we have 1 minus 2 plus 3 into 3 minus 4 plus 5 plus k equal to 0. So that is 2 into 4 plus k equal to 0, 8 plus k equal to 0, and we get the k value as minus 8. So now write the value of k in the equation 1. So we have x plus 2y plus 3 into 3x plus 4y plus 5 minus 8 equal to 0. So by simplification, we get the equation of the hyperbola. So that is 3x square plus 10xy plus 8y square plus 14x plus 22y plus 7 equal to 0. So this is the equation of the required hyperbola. So next, move on to the next problem. So these are all 2 marks questions, very important. So the question is here, if 3x minus 4y plus k equal to 0 is a tangent to x square minus 4y square equal to 5, then find the value of k. So this is a very repeated question. Here, what is given here? 3x minus 4y plus k equal to 0 is a tangent to the hyperbola. Here, this equation is hyperbola. So the given equation is x square minus 4y square equal to 5. Transform this equation into the standard form. We get x square by 5 minus y square by 5 by 4, which is equals to 1. Here the a square value is 5 and b square is 5 by 4. And the given tangent, that is 3x minus 4y plus k equal to 0. Now transform the equation into the form y equal to mx plus c. We have y equal to 3 by 4 x plus k by 4. So here m value is 3 by 4 and c value is k by 4. And also we know that the condition for a line y equal to mx plus c to be a tangent is c square equal to a square m square minus b square. C value is k by 4, that is k by 4 whole square equal to a square 5 into m square, that is 3 by 4 square minus b square, that is 5 by 4. So by simplifying, we have k square by 16 equal to 5 into 9 by 16 minus 5 by 4. Take the LCM. So we have 45 minus 20 by 16. So which is 25 by 16. So both sides 16 will get cancelled. So we have k square equal to 25. So then we will get the k value plus or minus 5. So this is very easy and very important one. Here we are applying the condition c square equal to a square m square minus b square. So next, move on to the next problem. So the problem is, if the eccentricity of a hyperbola is 5 by 4, then find the eccentricity of its conjugate hyperbola. So this is also very important and very repeated question. Let E comma E1 be the eccentricities of a hyperbola and its conjugate hyperbola. So yesterday we have proved a relation between the eccentricities of hyperbola and its conjugate hyperbola, that is 1 by E square plus 1 by E1 square equal to 1. So in this here, the eccentricity E is given, that is 5 by 4, and here we have to find the E1. So apply the E value, that is 1 by 5 by 4 whole square plus 1 by E1 square equal to 1. So that is 1 by 25 by 16 plus 1 by E1 square equal to 1. So on simplification, we have 16 by 25 plus 1 by E1 square equal to 1. Take 16 by 25 right side. We have 1 minus 16 by 25. So by taking LCM, 1 by E1 square equal to 9 by 25. And reciprocal the fraction here, E1 square equal to 25 by 9. So therefore, E1 equal to square root of 25 by 9, which is equals to 5 by 3. Therefore, the eccentricity of conjugate hyperbola is 5 by 3. So next, next problem is find the equation of the normal at theta equal to pi by 3 to the hyperbola 3x square minus 4y square equal to 12. Here we have to find the equation of the normal and given theta equal to pi by 3. So so this is the question here. So given hyperbola equation, that is 3x square minus 4y square equal to 12. Transform this equation into the standard form. So we get x squared by 4 minus y squared by 3 equal to 1. Here a square equal to 4 and b square equal to 3. Then a equal to 2, b equal to root 3. And the equation of the normal at p of theta, that is in parametric form, we have the equation of normal as ax by secant theta plus by tan theta equal to a square plus b square. Here it is given that theta equal to pi by 3. So now apply pi by 3 means 60 degrees. Apply the values of a, b, a square, b square and theta. We get 2x by secant 60 plus root 3y by tan 60 equal to a plus b, that is a square plus b square, that is 4 plus 3. So by cancellation, we get x plus y equal to 7. So which is the equation of the normal at theta equal to pi by 3. That is x plus y minus 7 equal to 0. So next question. So the question is, find the equation of the hyperbola whose asymptotes are 3x equal to plus or minus 5y and the vertices are plus or minus 5 comma 0. Here, the asymptotes of the hyperbola are given. So that is 3x equal to plus or minus 5y. So that is we have 3x equal to 5y and 3x equal to minus 5y. The equations are 3x minus 5y equal to 0 and 3x plus 5y equal to 0. So these are the equations of asymptotes. So we already know that if we know the equations of asymptotes, we can write the equation of hyperbola. So therefore, the equation of the hyperbola is 3x plus 5y into 3x minus 5y plus k equal to 0. So now simplify 3x whole square minus 5y whole square plus k equal to 0. So that is 9x square minus 25y square plus k equal to 0. So this is the equation of the hyperbola, and it is given the vertices are plus or minus 5 comma 0. We know that the hyperbola passes through the vertices. So now we can substitute the vertices in the equation. That is 9 into plus or minus 5 whole square minus 25 into 0 square plus k equal to 0. So simplifying 9 into 25 plus k equal to 0. So that is 225 plus k equal to 0. Here the k value is minus 225. Now substitute the value of k in the hyperbola equation. That is equation 1. That is 9x square minus 25y square minus 225 equal to 0. So that is 9x square minus 25y square equal to 225. So this is the equation of the hyperbola. Okay, that's all for now today. So tomorrow we will discuss the Roman number 2 problems. So prepare all these problems, very important. Okay, see you again.
Interesting.